The northwest of Alaska, located in US, has a very unique weather which is cold and dry climate with a frequent winter blizzard. In Alaska, they only have one operating surface coal mine, which is the Usable Coal Mine (UCM). Located near Healy, it can produce 1 million tons of coal per year, meaning that it can generate enough electricity to power 10,000 of homes in Alaska. Despite its advantages, coal power plant can lead to global warming, which is the main concern now that we will discuss in detail after this. The operation of a coal power plant can be described by several laws of thermodynamics, but the primary law that applies is the first law of thermodynamics, also known as the law of energy conservation. The first law of thermodynamics states that energy cannot be created or destroyed, it can only be transferred or converted from one to form another. In the context of a coal power plant, the law applies to the conversion of thermal energy released by burning coal into another form of energy such as mechanical or electrical energy.
Coal power plant release greenhouse gases into the atmosphere like carbon dioxide, methane, nitrous oxide, and carbon monoxide. As these gas emissions blanket the Earth, they trap the sun's heat, causing global warming, as mentioned before.
Mary, the project leader, proposed to make a new unique process of gas recycling and utilization. At first, she decides to grow algae to solve the issue, but the proposed method has some disadvantages. For example, growing algae needs a lot of land and water to work, and it requires a lot of maintenance too. That is why Mary assigned our team to find alternate way to solve this issue. So here is our objective. We have to recover and recycle harmful gases to a useful compound for the Alaska citizens. It is rather challenging as it is no easy task, but here is what we have come up with. We choose carbon dioxide, CO2, to recycle as it is a very common gas in our world. CO2 will be captured and converted to methanol. Methanol is already useful as it provides a clean energy resources used to fuel cars, trucks, buses, ships, fuel cells, boilers, and cook stove.
But that's not it. We decide to break down from methanol to propane. From propane to propane. Propane can be used for water heating, cooking, refrigerating food, clothes drying, powering farm, and industrial equipment.
With this suggestion, I assure you that we can make the life of citizens better than before as it is eco-friendly.
Let's look at how CO2 can be converted into propane. First off, CO2 will capture from the coal power plant. Then H2 is obtained from electrolysis of water. These two will undergo a process called CO2 hydrogenation with either zinc-based or copper-based catalyst at 250 degrees Celsius. These gases will produce methanol and water. After that, methanol will be converted to propane via methanol to propane process (MTP) at 450 to 500 degrees Celsius. And propane will undergo hydrogenation process with nickel as catalyzed at 462 to 677 degrees Celsius to produce propane.
From the proposed solution, there are a few factors that affect the rate of reaction. In this case, we are dealing with gas. So first of all, by increasing the pressure. For gaseous reaction, increasing the pressure will enhance the reaction rate. How do you increase pressure? Simple, by decreasing the volume. When volume decreases, the pressure increases. Higher pressure will increase the number of collisions between gas molecules of carbon dioxide and hydrogen. Next is temperature. Temperature plays an important role in the reaction rate of gases. Increasing the temperature provides more kinetic energy to gas molecules of carbon dioxide and hydrogen, making them move faster. After that, Increase in partial pressure of carbon dioxide and hydrogen leads to an increased rate of reaction. This is because higher concentrations result in more frequent collisions between carbon dioxide and hydrogen. All three of these factors result in a higher effective collisions and a faster rate of reaction.
Other than that, the addition of a catalyst can alter the rate of reaction. The carbon hydrogenation reaction requires a minimum amount of energy. This is known as activation energy. Now, for carbon dioxide and hydrogen molecules to undergo a successful collision, catalysts such as zinc oxide can lower its activation energy and allow it to react. The same goes for hydrogenation process, in which nickel will act as a catalyst. Lastly, due to the nature of carbon dioxide and hydrogen gas itself, factors such as molecular size, shape, polarity can affect the ease in which gas molecules collide and interact with each other. This would, of course, impact the rate of reaction.
It's important to analyze free Gibbs energy or delta G to predict the temperature towards the reaction. So, the equation for delta G is delta G equal enthalpy change or delta H minus with temperature times with entropy change, which is delta S.
Let's start off by finding the delta H. To determine delta H, Hess law needs to be done. There are three equations in total and also target equation. The first equation needs to multiply by 3 while equation 2 and 3 remains the same. Then, remove methanol and propene because it have the same mole on the product and reactant side. Then, add hydrogen, propane and water and voila, your end equation is the same as the target equation. After summing up all the value, the enthalpy change will be negative 374.2 kJ. Next is finding delta S. It's very easy because the formula for standard molar entropy change is the sum of mole times with entropy of the products minus with the sum of mole times with the entropy of the reactants. In this case, 1 mole of propane and 6 mole of water minus with 3 mole of carbon dioxide and 10 mole of hydrogen. The entropy change will be negative 1258.7 joule per Kelvin. After both value has been obtained, we can calculate delta G. It is confirmed that both value has negative sign, showing that this reaction will follow case 3 where it is temperature dependent.
At high temperature, the delta G is positive, showing that this reaction is non-spontaneous. Meanwhile, at low temperature, the delta G is negative, showing that this reaction is spontaneous.
The value of delta G in this case is 284.10 kJ, which is a non-spontaneous reaction.
To summarize, the operation of coal power plants contribute to global warming due to the release of large amounts of greenhouse gases like carbon dioxide into the atmosphere, which leads to various negative impacts on our environment and human health. An effective solution to address the environmental impact of coal power plants is to implement a proper unit process for gas recycling and utilization. So, our proposal to Mary is to recycle carbon dioxide gas to propane because it gives a lot of benefits to the citizens of Alaska, especially when they live in an abnormal weather, and also friendly to the environment.
Based on the findings, it is concluded that the reaction is not spontaneous at high temperatures, as indicated by the positive delta G value, which is 284.10 kJ.